Hi guys, Mark here, and today we're going to be looking at solving day 23 of the Advent of Code challenge in C# and F#. And before we begin, I've got something to show you today. If we look down the leaderboard at position 37, there I am. For the first time in this challenge, I've got on the leaderboard. And the only reason for that was my wife woke up at 4:15 this morning, and I thought to myself, well, the puzzle will come out in 45 minutes. If I'm still awake, I'll give it a go. And of course, 45 minutes later, I was still awake, and so I tried it, and thankfully it turned out not to be a super hard one like we've had in the last couple of days. I did it in just over a quarter of an hour. So let's have a look at the problem. The problem is basically we've got a computer, and the computer has got 6 instructions. It can halve the value of a register, triple the value of a register, increment the value of a register. It can jump to an offset, to another instruction, and it can conditionally jump. Jump if the number is even, and jump if the number is not odd, but is 1. And all we've got to do then is set our program going, and here's our program, and you'll notice that we've only got 2 registers, they are A and B. And we just have to run this program, and the question is, what will be the output in register B when the program is finished running? So because I was doing it against the clock and I still am quicker in C# than F#, I did start this in C#. So let me show you a slightly tidied up version of the code that I created. So I created a dictionary of registers, and as I said, we've only got 2 registers, A and B, and they start with values 0 for part A. Part B of the problem was actually quite kind. We just set the starting value of register A to 1 and run the same program again. Then parsing the instructions wasn't too hard. We just read all the lines from our program file. We split on space, and we trim off any extraneous comma characters. Then we start at instruction index 0, and we look at the instruction at that index, and if it's increment, we increment that register, triple, half, fairly obvious. Jump if 1, we look in the register, see if it's 1, and we parse the amount to jump by. Interestingly, int.parse in .NET copes with a leading plus. I didn't know whether it would do that or not, so you can cope with positive and negative offsets quite easily here. And so after we've updated the state and we've updated the index, and if the index is still inside the instructions, then we carry on running. And so that really was nice and simple. Now, I know in these problems I've been trying to solve things using LINQ, and today the only LINQ that I've used really was just a tiny bit to parse the input file. But really, this isn't the type of problem that it makes sense to try and force into using LINQ, because we're not sequentially going through these instructions. We're jumping forwards and backwards all over the place. So I think having a while loop here is perfectly sensible. The other thing I momentarily forgot when I initially created my solution is that in C# you can switch on a string. I was still stuck thinking back to my days many years ago of programming in C, where you can't switch on a string, but of course you can, so I refactored my solution slightly to switch on strings. Let's have a look at how I solved this in F#. And in F# I tried to go for a bit more of a functional immutable approach. This problem lends itself very well to using discriminated unions. So in instruction there are 6 instructions, and increment, triple and half have got a register, which will be a string that they're operating on. Jump will have an integer of how far to jump, and jump if even have the register to look in and the amount to jump by. And so this is a nice way of simply setting up what instruction we need. And so when we're parsing the instructions, after we've done the usual stuff of splitting on spaces and trimming off commas, we can then map using a nice pattern matching function that looks at the first value in the array to work out what command it is, and then picks out the parameters, converting them into integers where necessary. And then to actually run it, I've created a recursive function. And so the run function takes the index of the instruction we're on and the current state, and I've used a map object. In F#, a map is basically an immutable dictionary, and so I have gone for a totally immutable approach here. It's probably overkill. We could quite easily have just had a dictionary that's being updated with states, but I decided I'd give maps a go because I haven't used them before in F#. Then this function basically returns a tuple of the new state and the index of the next command. If the index is out of the range of instructions, then we'll just exit this recursive function. Otherwise, we will match the current instruction based on which of the members of our discriminated union it is, and we'll update the state if necessary, and we can do that by using map.add, which will create a new map with the key that we specify set to the value that we specify, and this is the amount to increment the index by. And if you look at jump, if 1 for example, then if the state at that key is 1, then we jump by the amount in the command, otherwise we just go forward 1 instruction. And so then all we need to do after we've done that is recursively call ourselves, adding the jump amount onto the current index and passing the state on. And so this means we can very easily run with a starting instruction of 0 and a starting state piped into the map function to create our starting map, and we get our answers out just looking at what's in register B. So F# solution was also nice and easy, and in fact, although discriminated unions are a good fit for this type of problem, it did feel like I was duplicating work, declaring it, parsing into it, and then matching on it. And really, we could have refactored this a little bit more and just said that in the run function we will match on the array of instruction strings and do it directly, and this gives us a much more concise solution. So that's it for day 23. I have been wondering whether maybe tomorrow's challenge might involve doing something more with this computer program, but we shall wait and see. So thanks for watching, and hopefully see you tomorrow.